Let's add and subtract these radicals that don't look like they are like radicals. Recall, we can only add and subtract radicals that have the same indices in the little hook and the same radicand under the radical sign. These don't have anything like that that matches. Well, some of the indices match, but they're not like radicals. So let's see if we can simplify each of them and maybe squeeze out some like radicals. We're going to do this by looking at the first square root of 8 and factoring a perfect square out of it. We're going to factor that as the square root of 4 times 2. That's the same as the square root of 8. And 32, we're going to factor under the radical sign as the perfect square 16 times 2. Now let's bust apart each of these radicals multiplicatively. The first one becomes the square root of 4 times the square root of 2 minus the second one becomes the square root of 16 times the square root of 2. That's the square root of 16. Okay, so let's evaluate the square root of 4 on the first radical. That is 2 times the square root of 2. Bring down the minus sign. Now evaluate the square root of 16, and that gives you 4. That's a 4, not a 2. It's a 4. All right, 4 times the square root of 2. Now, at this point, we're very happy because we have 2 square root of 2 minus 4 square root of 2. We can do this subtraction. These are like radicals. They have the same indices, the square root. They have the same radicands, too. We've got 2 of them minus 4 of them, and that gives us 2 minus 4, which is negative 2 times the square root of 2. Now, part B. Part B is 2 times the square root of 50 minus 3 times the square root of 125 plus the square root of 98. Doesn't look like we have any like radicals here, but we're going to simplify and see if we can get some like radicals. First of all, that 50 under the square root symbol, we're going to factor that as the perfect square 25 times 2. So it's 2 times the square root of, and under all the radical sign here, we write 25 times 2. So we replace the 50 under the radical sign with 25 times 2. Minus 3 times, let's see, 125 can be written as a perfect square 25 times 5. Plus, let's see, the square root of 98 has a perfect square factor embedded in it. It's 49. So we can write that as the square root of 49 times 2. Great. Okay. So we've got some perfect square factors that we can bust out of jail here. We've got the 2 times the square root of 25 times the square root of 2. See how we broke it up to the 2 different factors with radicals? Minus 3 times the square root of 25 times the square root of 5 plus the square root of 49 times the square root of 2. Okay, so that simplifies evaluating the square roots. 2 times 5 times the square root of 2 for the first term, minus 3 times 5 times the square root of 5, plus 7 times the square root of 2. Let's do a little simplifying. We get 10 square root of 2 minus 15 square root of 5 plus 7 square root of 2. Good news, good news. The first and the last term are like radicals. They can be added together. So we have 10 of them plus 7 more gives me a total of 10 plus 7, and their name is times the square root of 2. And then bring down the negative 15 square root of 5, and our final answer is 17 times the square root of 2 minus 15 times the square root of 5.